Hello, my name is Dennis Beatty. I'm here to talk about dynamic decision networks and EDGE, a new approach to non-player characters. I and Beverly McCarter are the authors of this paper. We have a strong team at Innovative Decisions Incorporated that's also working on this project. I've been working in this field for over 30 years and developed the concept of dynamic decision networks about 20 years ago. They've been applied in a number of real-time decision-making environments, and this application is to provide adaptive speech or text interaction between the player and the non-player character. Beverly has been working in the field of virtual environments for over 10 years and has advanced degrees in counseling psychology, fine arts, and virtual worlds. So the purpose of this talk is to address the issue of how can we provide more realistic training in virtual environments and essentially replace pull-down menus for the player to use to figure out what to say, and then a rule-based response by the non-player character. We're looking for something that's more adaptive, more exploratory, and provides better learning for the player in this environment. The Army is using the Enhanced Dynamic Geosocial Environment, or EDGE, as a way of implementing virtual environments for cultural situational training and attack the network. It's attractive because it's available 24/7, actors aren't needed, and they're very interested in teaching these kinds of conversational characteristics for use in other environments. And next chart. The key aspects of improving training for the player is to have a non-player character that has a psychological aspect to it that causes the player to be immersed and have a presence in the environment, that addresses the complexity of natural situations, that enables a player to experiment and get subtle cues as well as clues that knock them over the head. And finally, learning. The whole aspect of the whole thing about this is learning. And the Army, again, has gone on record by saying they've got to have soldiers that adapt in complex situations. That adaptation is not only important for the soldiers, but in the development community and the Army as a whole. And as far as the soldiers go, training is a very important part of it. So there's a spectrum of ways in which non-player characters can be designed. At one end of the spectrum, we have authorial control, where every situation is diagrammed out to minute detail, and the response of the non-player character in that situation is defined. And a rule base or some other kind of an approach like finite state machines is used in order to figure out what the situation is so we know what the response should be. At the other end of the spectrum is AI autonomy, where we've got a machine learning system or an automated planning system that's figuring out what the situation is and then is building a response for the non-player character from scratch. That technology is improving, but there's still a lot of issues in making it compatible with current training environments. The middle ground is called utility-based AI, and this spectrum was defined by a couple of authors in 2010 and 2012, Dave Mark and Kevin Dill. And our approach, dynamic decision networks, fits into the utility-based AI in the middle of the spectrum, just as the approach that Mark and Dill were proposing. Dynamic decision networks does involve building Bayesian networks in order to figure out what the situation is, but then doesn't build a response from scratch, but goes into a database and finds an appropriate response for that situation. Now, the situation is quite complex, as I'll illustrate on the next few charts. So an exemplary dynamic decision network, a relatively simple one for this application, is an influence diagram, which is the top three nodes, the impression node, the utility node, and the decision node. In this situation, we're talking about a non-player character that will tell the truth if the impression is positive enough, will walk away if the impression is negative enough, and will be evasive in the middle region where we've got a mixture of neutrality and some degree of positive and negative impression. The other nodes in that diagram are chance nodes and represent the Bayesian net aspect. And so we're going to be getting clues from each sentence that the player submits to the non-player character that will give us information about what how the impression should be building up over time of the non-player character for the player. Let's go to the next chart where we'll illustrate this in more detail. So the question that was asked by the player is, where is the bus stop? We notice that this is the first question in the conversation, and so in the leftmost box, 0 to 1.001 was checked. It's a sentence type is a question, and we have another Bayesian network that looks at where is the bus stop and figures out whether it's a question or a comment or a greeting or a pleasantry. The question, where is the bus stop, has no positive words, no negative words, and no inappropriate words. And so the probability of positive, neutral, and negative go from 40-40-20, which was the prior probability for this non-player character, to something like 27, 54, and 19. In other words, probability is building up in the neutral area, and that's the area where the non-player character is going to be evasive. And so if we now look at the utility or the decision node there, we see the highest utility is for the evasive response. So the Bayesian the dynamic decision network says we should behave evasively. So this is a simple example of how this builds up. The paper provides more detail in how it works. It's a relatively simple model. This was our first model for the first non-player character. We have finished that non-player character and have developed a more complex structure. We're now working on the second non-player character, which is also going to be a relatively simple character, but there's more complexity in the aspects of the decision, because rather than walking away, he will lie, and now we have to figure out what an appropriate lie is. And then the third non-player character that we're going to be doing is the medicine man in town. And he knows everyone, knows a lot about everyone, so the database of things this non-player character knows is substantially more extensive and therefore more complex. And I'll end it there.
I have a question for you.
Sure.
How much backstory is required for your characters for you to understand these subtle influences about how they evolve as characters?
Right. Quite a bit. Beverly McCarter has done a lot of cultural research on the region and has developed some ideas of what the characters are like. The writers of the game that go into Edge have also created a substantial backstory of who knows whom, who interacts with whom. There are 3 networks in town, the black network, which is the crime network, the white network, which is building a brick factory that the red network doesn't want to be built, and the military is coming in order to try to keep the peace and to enable the brick factory to be built because it will bring tourists in and make this region more dynamic and wealthier. It's a very poor region in Azerbaijan. So a lot of research needs to be done. On the other hand, one of our prime development objectives is to create a number of knobs that will allow the game team to change the non-player characters once all the research is done by turning maybe a half a dozen knobs rather than getting inside and tweaking all the numbers and all the other aspects of the model.
Thank you.